If we are tasked with multiplying rational expressions, fortunately for us, the process for multiplying rational expressions is almost identical to the process that we use simply to just simplify them, factor, and cancel. When we're multiplying rational expressions, we don't want to go through the hard work of actually multiplying both of the numerators together and multiplying both of the denominators together, because once we do that, the goal is then going to be to factor and cancel. It's going to be a lot easier to factor them when they are in these simpler forms than if I try to multiply these binomials and trinomials together and then refactor everything. So I don't want to go through the trouble of trying to do all of that algebra. I just want to say, I know that this numerator has some factors. I know that the denominators each have some factors. I know this numerator has some factors. So I'm going to take advantage of that, not have to multiply them all together, and then just do the cancellation across the two fractions. So if we're just going to factor everything, we're going to go piece by piece. Here's the numerator of the first fraction. Here's the denominator of the first fraction. Both of them are difference of squares. The numerator of the second fraction is a trinomial that factors as x minus 3 and x minus 2. The denominator of the second fraction is also a trinomial that simplifies or factors as x minus 3 and x plus 1. And then across the two fractions, we're just going to do our simplifying numerator to denominator. It's almost as if this multiplication dot is not there and this is one big fraction, because that's what it essentially would be. If I was to multiply them together, those numerators would come together and those denominators would come together, and then I would be able to just simplify them like that. So I don't even need to go through that step necessarily. I have them both factored like this, and now I can just start crossing out. So I've got an x minus 2 here and an x minus 2 here. I've got an x minus 3 here and an x minus 3 there. I've got an x plus 1 here and an x plus 1 there, leaving behind two factors that make up my final response, x minus 1 and x plus 2. Just as we did for the previous questions, we want to think about the restrictions on the variable, knowing that x cannot be 2, x cannot be negative 2, x cannot be 3, and x cannot be negative 1, change our conversation a little bit if we wanted to transition to thinking about this as a function that needed to be graphed. Let's try another example of the exact same idea. Factor and cancel, not trying to multiply the two of them together. Looking at each numerator and denominator separately, and then simplifying what we can. So x squared plus xy, not a special pattern, but we see a common factor of x. So we're going to remove that common factor of x, leaving us with an x plus y. The denominator, a difference of squares. I know this denominator of the second fraction is not going to factor to anything because it is that lone monomial. And then the numerator has a common factor of a 4, removed with an x minus y. As you go through this process and you get more experienced with this simplifying, you'll notice that you're going to be looking for things to simplify. It's not going to be a matter of just hoping for the best and blindly going into these problems. I had a pretty good idea once I did this factorization that x plus y was probably going to show up somewhere else. Not a guarantee, but it's a pretty good suggestion. Same thing once I had the x minus y right here, I had a pretty good idea that x minus y was going to show up somewhere else. And it did, and so we simplify them. We have one last common factor that sometimes is missed very easily because it kind of sneaks in and it's not as obvious as the other factors, and that's the x. If you look at all the simplifying that we did, three different factors on the top, simplified with 3 different factors on the bottom, leaving us with just 4 as our final answer. So the simplified version of this big multiplication is just 4. And truthfully, you probably wouldn't have got there if you tried to multiply those two together and then do it. It's a lot easier to leave them separate and factor and cancel separately. One last thing, giving special consideration again to our restrictions. Here we have 2 variables, so we have to consider those 2 variables sort of together. This factor tells us that x should not equal y. This factor should tells us that x should not equal negative y, and this factor, one of the more obvious ones, tells us that x should not be 0. Looking at each one of those factors and setting them equal to 0, thinking about what they would be in terms of a restriction, what they're not allowed to equal. Moral of the story for this set of problems, we're looking at these examples. We're not trying to jam them together. We're not trying to go through the hard work of the multiplication. We're factoring each one of the numerators and denominators separately and then simplifying what we can. This is an exact replication of the skill that we saw in the previous part of the lesson, just now 2 of them at a time. And theoretically, you could do this with as many of them as you want at a time. There's no limit. As long as you're willing to engage in the factor and cancel tradition, these examples follow just like those from the previous part of the lesson.